So we are going to wire a logic 1 up to forward out, which means when we load this and turn the power on, we should basically get the wheels spinning in the forward direction. However, we don't want wheels spinning in the forward direction and the reverse direction at the same time. So we're going to put a logic 0 here. I'm just going to do a Control C, Control V, Control C, Control V. And so now you can see it's not going to go reverse, it's not going to go left or right, but it is going to go forward out. And because we are putting a 1 through this OR gate, it will go at the maximum speed. So that's all we have to do for now. And we'll go through and then we'll test each one of these by changing this to 0 and then changing the next to a 1 and so on. And that will allow us to test to make sure that the PSoC is capable of driving the motors properly. And then we'll get into more logic here to control the car. In case you haven't noticed, we actually haven't written any software. This PSoC board has an ARM processor in it, and when you create a new project, it gives you basically a kind of a generic main section in here, and you can basically see what it is. So it does an interrupt enable, and then it goes into this infinite for loop. So we haven't written any software yet. We're starting to control the car, and we're doing that because this is implemented in hardware. It's implemented all in logic. Now, there is one thing that we have to do. We have to go into the PWM, go to the data sheet, and let's see if there is an initialization section for the software. So here's the application programming interface, and yeah, so these are the functions that are available to us on the PWM. So you can see the first 3 letters here, PWM, and then underscore start. So what we have is name is PWM underscore 1. So what that means is we are going to say PWM underscore 1 underscore start when we want the PWM to start or stop or any of the rest of these. So this leading name here is generic, and we have to change it to what's specific to our code. So for now I'm just going to initial it. I'm assuming that it will come up disabled, but just to be on the safe side, I'm going to do a stop call in the main code. So here's where we can place our initialization code. So I'm going to come in here and say PWM underscore 1 underscore stop with a capital S, parens, semicolon, and now we've at least initialized the PWM device. I'm not sure if the system will complain, but anyway. So let's save that. Let's go back up here. Now, there are a few things we need to do. As you can see over here in source files, we don't have any of the PWM function calls yet. So now that we have this PWM on our schematic, we have to do what's called build application or generate application. So what that'll do is that'll go out, it'll identify the PWM, and boom, now it has loaded all of the functions that we need from their library. You can see yeah, there's PWM1. So here's PWM1, here's the PWMC and the header file and all the stuff it contains. What is also interesting is you can see that we have code for each one of these pins. So you can control these pins either from the main software program or you can control them in hardware. And so the motto apparently of the Cypress folks is hardware first, and then whatever you can't do in hardware, go to the software. And we're going to get into that a little bit, but for now we can see now we have all this capability built in. It's pretty amazing how they do this. It's just so easy. Now you can see we're getting some warnings down